In this video, we will discuss what's a general definition for vector. Okay, so whenever you hear a word vector from your high school physics, you will imagine that vector is something as a physical quantity which is having a magnitude as well as direction. Okay, and when you try to imagine the vector, you will imagine the vector with some arrow mark. Okay, and that way of geometrical representation is okay for two-dimension vectors as well as for three-dimension vectors. But what if it goes beyond the three-dimension, like four-dimension, five-dimension, or 100-dimension? Okay, even in physics, even in some engineering application, we have to deal with such a larger dimension vectors. Okay, so in that case it's difficult to imagine. But what's a vector? Okay, so we are going to give a general definition what's a vector. Okay, and from there we will give a new understanding about the vector. Okay, so in order to understand a vector, first we need to know a vector space. Okay, so this is a page about vector space in Wikipedia. Okay, and so vector space is a set. Okay, it's a set of elements and each element is represented as a vector. Okay, so that's what the vector space means. Okay, now how can I define that vector space? Okay, so in the vector space we need to define, so this is the definition, notation and definition. Okay, so along with some set, okay, I have to define some set, and that set, along with that set I have to define two operations. Okay, the first operation is called vector addition. Okay, and the second operation is scalar multiplication. Okay, so one is vector addition, another one is scalar multiplication. So what this vector addition will do? The vector addition will take two vectors and give me a vector. Okay, which means from that set it will take two elements and give me an element which is within that set. Okay, so I need to come up with a set. Along with that set I need to come up with this, the addition rule, vector addition rule. Okay, and then a scalar multiplication rule. So what is that? That I have to take a scalar value, okay, and I have to do some operation which is defined by the scalar multiplication. Okay, and that should provide me a new vector. Okay, and that new vector should be once again within the set. Okay, so I'm not just defining the space or a set, but also additional to that I am defining the two operations, vector addition and scalar multiplication. Once I define it, can I call that as a vector? No. That set along with those operations has to follow certain axioms. Okay, so these are the set of axioms. Okay, associativity, commutativity, identity element, inverse element. Okay, all these properties has to be satisfied. Okay, so here the meaning of those properties. Okay, and for a column vector or a three-dimension vector, you can easily verify these axioms. Okay, and that's the general meaning for a vector space. Okay, and each element in the vector space is a vector. So as an exercise, what you could do is you just consider maybe a three-dimensional column vector and check whether all these axioms are being satisfied. Okay, so yeah, so that's what the vector space means and the vector means. Thank you.